Go.
Today we will be talking about the production of unconventional gases. The production of conventional gases has reached its peak, and now oil is starting to change form, geographically, economically, and chemically. The world is approaching the end of an era to access fossil fuels. With the help of advanced technology, a new source of oil is starting to be exploited. Unconventional gases are becoming a significant source of hydrocarbon supply in North America. Tight gas, shale gas, and coal methane are all known as types of unconventional gases. Advanced knowledge and modern techniques are allowing better access to these types of gases.
Go.
Unconventional gases are sources of natural gas that are considered to be difficult to produce and obtain. Natural gas is created from the production of shale gas and tight gas. Shale gas is found in fine-grained organic rock, and tight gas is natural gas found in low permeability rock, such as sandstone, siltstone, and carbonates. Studies on shale gas show that if we were to drill into a rock with extremely low porosity, production will be extremely slow. Now, because it's so slow, it's infeasible on an economic standpoint. Shale gas is economically attractive because of two very important technologies, one being hydraulic fracturing or fracking, and the other being directional drilling. They made it possible to recover natural gases at an increasing rate. However, since this technology behind producing unconventional gas is relatively new or at its infancy, machines designed are not fully capable of functioning at maximum efficiency yet. Projections show that by 2040, production of both tight gas and shale gas will increase dramatically, especially in North America, because that's where gas was pioneered. Now, we have a chart that shows just how much both tight gas and shale gas would increase. As you can see, the non-associated onshore and non-associated offshore is at a normal level by the time 1990 and 2011. But after hitting 2011, you can see a dramatic decrease in both the non-associated onshore and offshore. But you can see a huge increase in both tight gas and shale gas, more so in shale gas. And we're going to show a video on the production of shale gas and why it is so important, and we can show the benefits and the negativities towards it.
Shale is a sedimentary rock derived from clay, the most common on Earth, some forms of which contain methane gas. Huge shale deposits can be found across the world, and reserves are estimated at 448,000 billion cubic meters, the equivalent to 140 years of global gas consumption at current levels. Half of the deposits are to be found in Asia and North America, but harnessing the gas is technically complex, because unlike pockets of natural gas, it is impossible to pump directly as it is embedded in the rock. But it can be extracted using a process known as hydrofracturing, or more commonly, hydrofracking. A rig drills deep into the ground to reach the shale deposit, then continues horizontally, often for several kilometers. Huge quantities of water are then injected into the hole. The pressure cracks the shale, releasing the gas. The process not only demands millions of litres of water, but also chemical products. And only about half of the water and chemicals can be retrieved, while the remainder can seep into the water table with possible harmful effects for drinking water. A further source of pollution is the inevitable escape of gas into the atmosphere during extraction, as methane is one of the main contributors to global warming. All of which makes shale gas a highly controversial form of energy. However, shale gas extraction is now commonplace in the United States and Canada, and the process is gaining ground in China, Australia, and even in parts of Europe.
Go.
Conventional gases are found in reservoir pools formed by gas collection over a large period of time underground. These pools are formed from traditional permeable reservoirs, which travel and collect in pockets, forming pools of natural gas. Now, through the extraction of vertical drills, we are able to retrieve the gas, specifically unconventional gases. Because these pools are generally located in the same area, the use of a single or very few vertical drills would allow for the extraction of the gas almost entirely and very efficiently. Unconventional gases, however, generally shale gas and tight gas, cannot be extracted through the methods we mentioned before, due to the location and characteristics of unconventional gases. Unconventional gases are formed through collections between sheets of rock instead of pools, such as conventional gases. These collections of gas stay within the layers of rocks instead of collecting, causing vertical drills to be very inefficient. However, through multilateral drilling, we are able to attain more of these gases, regardless of their location. What multilateral drilling allows us to do is to drill horizontally or in any other direction. As shown in the previous video, unconventional gases are collected in layers underground, layers and sheets such as the one shown here, in which the branches of the drills themselves would then be able to extract. However, unconventional gas drilling is currently extremely costly and harmful to the environment due to the infancy of the stage. These factors can be heavily reduced with the use of more research and more dedication to this method.
Unconventional gases have the ability to provide us with a new source of energy and materials. These gases need to be better understood so that we can understand their potential uses and the methods used to obtain them. An experiment that was conducted by the Earth Science Research Institute and that was eventually published in the journal Organic Geochemistry studied the effect of sediment size and composition on the production and quality of methane gas. The researchers utilized a technique known as pyrolysis to learn more about the production of these unconventional gases. Pyrolysis is essentially the decomposition of sedimentary rocks in the absence of oxygen. The products of this reaction are carbon-based products and hydrocarbons. These products can be analyzed using gas chromatography or a flame ionization detector. The first part of the experiment explored the effects of various kerogen compositions on the gas that is produced. Kerogen is the organic material that makes up sedimentary rocks. The composition of kerogen varies from rock type to rock type. Some kerogens are high in hydrogen composition, while others are low in hydrogen composition. Basically, the location of where a certain rock type is found impacts its chemical composition. The researchers found that sediment that had kerogen that was rich in hydrogen produced a wetter gas, while the sediment that had kerogen that was lower in hydrogen produced a drier gas. They also found that the sediment that had kerogen that was higher in hydrogen content produced more methane than kerogen that was lower in hydrogen content. A drier gas, indicated by a higher percent methane, is generated from hydrogen-poor sedimentary rocks, whereas wetter gas, a lower percent methane, is generated from hydrogen-rich materials. Table 1 outlines these variations in kerogen types and its impact on hydrogen gas composition. The second part of this experiment studied the effect that size and quality of the sedimentary rocks had on the gas product. The researchers studied rock types that were in a chip form and rocks that were in a powdered form. The researchers found that sediment that was chip-sized grains produced more methane than the sediment that was finely powdered. Table 2 outlines the variations in percent methane between these two rock types. Understanding the different kerogen types and rock types is critical for scientists to understand to be able to more effectively get the type of gas the scientists need.
Unconventional drilling is extremely expensive due to the lack of the advancements in technology that is necessary to efficiently produce the gas. Downsides such as the cost and other, mainly environmental, are caused due to the infancy of this development. When unconventional gas is released into the air, some of it will turn into methanol, which obviously is extremely bad. There are also circumstances with the quality of land and water. Water contamination is caused through spillage and leak caused by the drilling itself. With more dedication to research and time pertaining to this subject, the price and effects will definitely decrease and hopefully eliminate all of the downsides. So, despite some of the negative aspects, there are still many reasons as to why the production of unconventional gas will become the most prominent source of energy. Being capable of accessing such amounts of efficient energy would not only allow for income and current to flow within the nation, but also provide a new source of non-renewable energy. In comparison to fossil fuels, natural gas is more environmentally sustainable.